Hi, everybody. Thank you so much for having me here today. Filecoin and the Electric Capital presenters did a really wonderful job teeing up a conversation around interoperability and why Omnichain assets matter. So we're going to dive in right here. I am head of strategy at LayerZero Labs, and LayerZero Labs is the creator of LayerZero. We're going to be going through cross-chain messaging principles and what informed our unique protocol design, as well as why Omnichain assets matter and how to build with them. And we'll conclude with some really exciting metrics around growth of cross-chain dapps and also some really novel use cases that we're seeing. So what is Omnichain interoperability? Interoperability between blockchains is the enablement of data and information transfer between disparate blockchains. Our aim at LayerZero is to enable smart contract communication between different L1s, L2s, rollups, and it's important to keep in mind that when we talk about different networks, these aren't different cities or countries. A more accurate analogy would be that they are like different planets. So what is a trustless and decentralized way to verify that something has happened on one chain when you're on another? This is where interoperability comes in, and unified information as well as unified assets play a really huge role in this. We all know from using existing dapps that there are a lot of different steps and different tokens that are necessary and a lot of churn that happens through the process of trying to actually complete a transaction across different chains. Interoperability is how we can abstract away this multi-chain complexity. So it enables a radically improved user experience. You can now design applications where you can lend on one chain and borrow on another, all while only needing one gas token. You can improve your own developer experience by enabling really creative gameplay design, for example. One thing that I saw that was really inspiring at GDC earlier this year was gaming studios leveraging cross-chain messaging to create a user experience where an action is implemented on one chain, let's say a subnet or a supernet, and that triggers a message from the supernet to Ethereum, where that user's Twitter PFP lives. That message then mutates the metadata and transforms the artwork of the Twitter PFP. So now what you have is a user who killed a boss in their game, and immediately their Twitter PFP has a crown. So that's a very primitive but creative use case that developers can start to run with and create more fun and engaging and simplified user experiences with. And then finally, composability. Now what you create on one chain has meaning in an entirely different ecosystem. And so there's synergistic user experiences across networks. So then what is LayerZero? LayerZero is the leading omnichain interoperability protocol. In essence, it's a generic messaging primitive that enables arbitrary contract invocation. With LayerZero, you can send messages, packets of information from a smart contract on one chain to a smart contract on another. And that means it can be applied for use cases across DeFi, across gaming, NFTs, TradFi, consumer fintech, and also infrastructure. I alluded to some of those really exciting use cases, particularly in gaming, but later when we get into Omnichain assets, you'll start to see that for a DeFi protocol, for example, by issuing your protocol token as an Omnichain token, you can grow your user base and also supply much quicker and also decrease barriers to entry and engagement with your protocol. LayerZero aims to solve this holy grail problem of unifying disparate chains like I alluded to before. But as we all know as well, we have a protocol that sits on one chain and a protocol on another. And if we're trying to onboard another 100 million users into Web3, the belief that they should have to know and care about the differences between Polygon and Solana or Aptos and Sui are incredibly naive. If you've ever spent time with a grandparent or someone who's not familiar with crypto, you'll notice very soon that it's quite alienating to deep dive into the specifics of a particular network. We, of course, are early movers in the space and are developers, and so it's exciting to us in the same way that in the late 70s and early 80s, the advent of TCP/IP was incredibly radical and also exciting for developers during the transition of the intranet to the internet. And so TCP/IP is a very accurate analogy to thinking about what LayerZero is and how it serves developers across blockchains. We are now unifying these disparate networks. And so you can abstract away multi-chain complexity and design for the next 100 million users by enabling cross-chain messaging. The core concept of LayerZero. We got into this before, but our unique protocol design was meant to be open and permissionless, and also incredibly easy for developers to implement into existing protocols. And so if we dive into this architecture right here, what you'll see is that you have chain A and chain B, and endpoints that exist on these two chains. These endpoints are smart contract libraries. And later in the talk, I'll dive into why we designed LayerZero to be modular and allow for new smart contract libraries rather than a fixed design and a fixed security layer, capturing perhaps in this moment what is a best validation technique but might not be 10 years from now. From the endpoints, which are the developer-facing interface, messages are passed through and state data is broken up and retrieved and submitted by independent entities, which we refer to as the oracles and the relayers. And I see these as a plural because in this design, applications can choose to decentralize with an infinite number of oracles and relayers. The oracle's sole role is to retrieve and submit a block header, and the relayer's sole purpose is to retrieve and submit a transaction proof. So what are the three ideal principles for cross-chain messaging protocols? In the design of LayerZero, we cared a lot about the ethos that ultimately brought us into the space and some of the core design issues, but also like regulatory issues that we feel are important for developers to keep in mind. And so one is immutable. The second one is permissionless, and the third is censorship resistant. So we'll dive into what those three ideals mean in the design of LayerZero, but also your considerations for all cross-chain messaging protocols. So the first one is immutable. There are upgradable smart contracts and immutable smart contracts. When you push an immutable smart contract, it means you cannot go back and upgrade to fix a bug. It's there, it's frozen in time. Uniswap, for example, is very well known for being a shining example of a protocol that's comprised entirely of immutable smart contracts. The issue with designing a cross-chain messaging protocol with upgradable smart contracts is that every upgrade resets security. You have tried and tested a certain set of smart contracts, and they have protected, let's say, $1 billion of user assets. But now you push new code, and there may be a bug in it. In fact, the primary reason for all bridge hacks over the last year, and there were billions of dollars lost, was because of smart contract bugs, not because of core architectural flaws. So every upgrade resets all security. In addition to that, every upgrade exposes all applications built on top of these smart contracts to contagion risk. So there's existential risk for applications that are leveraging this infrastructure. An unfortunate example of this was a bridge hack that happened last year. Again, a benign mistake, an intention to upgrade a contract to enable a new feature, and ultimately all the applications that were built on top of this bridge were drained of funds. That bug was implemented by a core protocol developer. So even benign developers will make mistakes. And I often say, if you are a protocol founder or developer and your biggest fear when you go to bed at night is not smart contract bugs, you're kidding yourself. Like, that's what keeps me up at night, and it should be what keeps you up at night as well. So pushing only immutable code is incredibly difficult, and it's something at LayerZero that we've been committed to since day one. All smart contracts we push are immutable, and this means that for every line of code we push, even if it's a 4-line smart contract, we go through multiple security audits and then internally implement what we call NASA-level security measures. We create red and blue teams and administer sort of fake attacks internally, and we also go through really robust code review processes. So that's just touching the surface of what your teams can do so that when you're pushing immutable code, you are ensuring that you are keeping yourself and your team to the highest standard. This is a visual representation of what protocol upgrades do to applications that are built on top of your protocol. So in the red section here, you can see all the lost security when code upgrade occurs. In that blue area is the upgrade to new code. So the solution to this with the LayerZero design is that it's incredibly modular and is based off of smart contract libraries, as I said, these endpoints. So By LayerZero's design, we can actually publish new endpoints which applications can opt into or opt to point towards. So that means we could potentially publish a smart contract library that leverages ZK technology, and applications, once they go through the code or see that it has been tried and tested, can opt in. This also means that 10 years from now, when there's new research and new validation methodologies, we can offer those as options for applications to opt into. We believe that the best research practices of today will not be the same 10 years from now, and so the security we buy into today should not be the security we buy into 10 years from now as well. And it doesn't reset the security clock for applications. They get to own their security and have agency over what their users are exposed to and the security layer they buy into. The second principle here is permissionless. LayerZero is designed to be open and permissionless forever. That means any developer can go and use our infrastructure and build what they'd like. There's no censorship from our team, and that's an ideal and ethos decision from our part that aligns with a lot of the reasons why we, the developers at LayerZero, got into the space to begin with. This also means permissionless participation in the validation methods and network that underlies LayerZero. So applications can choose to run their own oracles or relayers and do not need approval or necessarily support from the LayerZero Labs team to do this. This means also that if the entire LayerZero Labs team disappeared, or if we resigned, or some horrible accident happened, LayerZero as a protocol would exist in perpetuity. So all 600 unique applications can continue leveraging the protocol for cross-chain messaging and can continue swapping in and out the different oracles and relayers that are used in the decentralized security across the protocol. Without immutability, if the entire protocol were based off of upgradable smart contracts, permissionless would not be guaranteed. And so that's incredibly important when you think about what is a protocol versus a service. And if you're building an application and you will be leveraging cross-chain infrastructure, which our belief is that over the next 5 years, all applications will. All applications will have a smart contract that leverages the best of Filecoin VM for storage, or then under the hood, processes settlement on Solana, and then also enables liquidity pathways on Ethereum. You need to be thinking about the dependencies that you're buying into, and permissionlessness is incredibly important. Finally, censorship resistance. This is something that is probably on a lot of your minds, and I alluded to before when I was talking about regulation. There are many instances of Ethereum validators having to censor particular transactions because of regulatory reasons. If you design your technology or you design-based infrastructure to enable censorship, it will happen. You will have to mutate your technology to conform to the regulatory environment. LayerZero was quite literally designed so that we cannot censor messages. Messages cannot be reordered. This is called nonce order enforcement. And LayerZero is the only messaging protocol in the space that is designed in this way. This means that validators cannot reorder delivery of message or censor individual messages, let's say because of a desire to front-run a transaction. No high-frequency trading firm could use LayerZero in that way. Applications can also always choose different off-chain infrastructure if they'd like. And this goes back to the point of owning your security and leveraging a true protocol versus a service that relies on the owner company to maintain its offering. And once again, without immutability, censorship resistance is never guaranteed. If you're building on top of a protocol that is upgradable, this can all change at any moment. Some examples of upgradable smart contracts are, for example, like a bridging or one-time migration of a major NFT project. If the creator of those smart contracts can then go in and fix a bug, that also means they can go in and move all the underlying assets. We have to be thinking for our end users and designing for perpetuity. I think oftentimes the timescales in Web3 and crypto are so short that we're thinking about designing for 6 months from now, but what about 10 years from now? Or what about after you're gone? We want to be designing systems that live on and are evergreen. So now to Omnichain assets. LayerZero created these two standards, which we call the OFT and the ONFT. OFT stands for Omnichain Fungible Token, and ONFT stands for Omnichain Non-Fungible Token. These are two ways you can mint assets that exist natively on multiple chains. There are also ways that you can convert existing assets on a single chain into Omnichain assets without ever needing to go through a wrapped token bridge. On the right-hand side, you can see there are actually 3 really adorable examples of NFT projects that have adopted ONFT. So there's Pudgy Penguins, Kampai Pandas, and Tiny Dinos. Most recently, Pudgy Penguins, which was originally an Ethereum-based collection, adopted the ONFT standard to open up the portal so that holders and community members, new ones, can move their NFT from Ethereum to Polygon, BNB, and Arbitrum back and forth, whichever way they'd like, and do so without burning and minting. The ONFT standard maintains provenance. That's incredibly important for high-value NFTs, but also really important when you're trying to design user experiences where the metadata and movement and usage, utility of the NFT matters wherever you bring it. So Omnichain assets allow you to securely transfer these assets across chains without wrapping, middle chain, or liquidity pools. It's the ultimate form of an extensible token contract. This means that your application or your developer team owns the contracts. The underlying messaging protocol or service does not via the ONFT standard or an OFT standard. You own your own security via the architecture I'd shown before. And you own your fees as well. If you wanted to, you could add a fee for every transfer between chains. Ultimately, it allows the entire ecosystem beyond individual chains to compose what you've built here. And the Pudgy Penguins example is one that's super fun, and if I had time, I'd go into a demo of it, but otherwise, encourage you guys to play around with moving NFTs between chains. Additionally, by minting Omnichain assets, you can drive user adoption and grow your supply of tokens. So these are some examples of projects that have converted their protocol tokens into OFTs. PancakeSwap, for example, converted their cake token into an OFT, and this has driven enormous growth and allowed them to expand very quickly into the Aptos ecosystem. They are now the leading DEX across all of Aptos by a magnitude. And it's been incredibly impressive to see. Stargate, which is the native asset bridge which LayerZero Labs launched about a year ago, also has been an OFT since day one. Trader Joe launched their Joe token as an OFT recently to huge fanfare from their community. And a really exciting example is BTCB, which is one of the most widely adopted versions of Wrapped Bitcoin, which Ava Labs issued as an OFT a couple months ago. This is a graph that shows the messages or the transfers of BTCB before and after they adopted the OFT standard. And you can see that right on the right-hand side graph. Even more exciting, the supply growth doubled afterwards. And since then, the adoption of BTCB has been really quick across new ecosystems. So it's now not an asset that is unique to the Avalanche ecosystem and siloed there. It will never be wrapped also. There's no incentive for it. In all the new ecosystems where BTCB has launched, which is all the ecosystems that LayerZero supports. We support 30 EVMs and non-EVMs and growing. Our roadmap is every single chain. BTCB will be native there without needing external liquidity. So this is a really interesting method for games, for example, to mint their in-game currency so that it's native in their subnet or their supernet or their app chain, but is also native back on the main chain or Ethereum mainnet as well. Incredibly important for liquidity, but also ease of use. So you now abstract away the need to go through a third-party bridge, pay extra fees. Instead, it's just a transfer between chains. Now, this is my favorite slide. It's also the last slide. This shows on the left-hand side cumulative contracts on testnet built on LayerZero, and on the right-hand side, contracts built on mainnet. So we're at almost, and I actually think this morning, 30,000 contracts on testnet, and then on mainnet, nearly 6,000. So this means that over the next year, we're going to be seeing so many new projects and applications that are chain agnostic or cross-chain and are leveraging LayerZero to enable this abstracted user experience. I have seen incredible protocol innovation from DeFi teams. For example, lending on one chain, borrowing on another. That's a very simple use case. But what about now offering index tokens that are native everywhere? And then compounding your yield from that in really novel use cases. For gaming, it's not just the innovative gameplay of having an action on one chain propagate some mutation on another chain, but you can also issue all of your in-game skins, accessories, prizes as ONFTs. So now these are meaningful across different chains. And so if you're creating a game, like I said, that is connected to Clayton to bring in an ecosystem in Asia, and connected to Solana and Polygon and Ethereum, and engaging all of these communities, now they can mint from whichever chain they'd like or purchase NFTs from another chain using their native source gas token. And as a designer, if we have any designers in the audience, there are so many huge steps forward you can do with that underlying technology. You can now make transactions as simple as, like I said, one click, and you can even build it exactly into the gameplay. For TradFi, we're already seeing and are working with really fantastic institutions that are enabling permission change to public chain communication and value transfer. And for consumer fintech, they are still really bullish on crypto and want to enable cross-chain swaps natively within their wallets, for example. And that's something that LayerZero enables. And so my call to action to all of you is whatever you're building, I want to hear it. I love jamming on protocol design and also ways to bring Omnichain assets to your communities, to improve user experience, to take away the security risk from end users. In Web 2, the best user experiences are the ones that, one, reduce churn, make it as quick and easy as possible to get to the underlying value you're trying to unlock, but also one that eases your mind of any concern or clunkiness or risk. And with wrapped assets, you are constantly carrying around an IOU or a synthetic asset that says to you, if the bridge you've gone across is hacked and you don't cross it back in time, you don't pay that fee to cross it back in time, you're left with a meaningless asset. Now, with Omnichain assets, it's the real deal wherever you are, it's canonical, and it has meaning in applications across all ecosystems. So that's the presentation for today. There's so much more to come. We'll be sharing a lot of really exciting announcements about more developer tooling, public goods, and use cases, but I mostly want to hear from you all, so please feel free to find me after. Thanks for having me.